Hello students, today we will start memory read machine cycle. As I have told you that in upcode fetch there are 4 or 6 T states, but in memory read machine cycle 3 T states are required for this. So you have to draw, first of all you have to draw 3 T states, T1, T2 and T3. Whenever we have to draw any timing diagram, we have to draw the clock pulse first of all. I have already told you how to draw the clock pulse. Now first of all draw the clock pulse. After that we have to give the status of address and data bus. So we will draw a higher order address bus. Now for the memory read, it means microprocessor is reading the data from the other peripheral device, and that means there is a flow of data from memory to microprocessor. That means if this is a memory, so from a particular address microprocessor is having the data. Now microprocessor can access only 8-bit data at a time. So 8-bit data is moving from memory to microprocessor in case of memory read. Now how much of time is required for this processing? There are 3 states that are required for this processing. So for this memory flow, 3 T states are required. So this is known as memory read cycle. In this, higher order address, status of higher order address would be the higher order address from where the microprocessor is going to have the data. So that means if we are talking about 4014 address, for example, microprocessor is taking the data from this address. It means that 40 is the higher memory address and it should be in A15 to A8 status. We will draw that status by a binary line, 2-state line. It means it can be 0, it can be 1. In 40, what will happen? 0, 1, 0, 0, 0, 0, 0, 0. So these are the 8 lines status A15 to A8. You will write here only memory address and the memory address given in your example. Whenever these type of machine cycles come, you have to give the example along with the timing diagram. Now after that, either you start with the ALE or you start with directly with the address data bus. This is your choice. Now let us start with the ALE signal. Address latch enable is always high at T1 state and it is off at T2 and T3 states. So we will draw ALE signal high at the T1 state. So it is high at the T1 state and it is low for the rest of the states. Now it is high, it represents that whenever it is high, address data bus acts like an address bus only. So for the T1 state, address data bus is only the address bus. Which address bus? It is the lower order address bus. Here 40 is the higher and 14 is the lower. So here it comes 14. So this is the total status of the address 4014 at the T1 state. So whenever microprocessor has to read something from the memory, first task is to place the address at the address bus. So 4014 is the address from where it has to get the data. Now how it gets the data? Whenever it gets the memory read control signal. Whenever this control signal comes to the microprocessor, it will get the data from the memory. So that is the status of data bus. This is the status of data bus. So same bus is used as address bus as well as data bus. Now this data bus is from mid of the T2 state to the mid of the T3 states, as I have told in upcode fetch also. So next signal is control signal. You have to give the status of address bus as well as control signals. Now IO by M bar. In case of IO by M bar, it is memory related signal. So you will write here IO by M bar is equal to 0. If it is IO related signal, it should be 1. Now IO by M bar is 0 in this case. Now status for the memory read is 1 and 0. You can also draw like this. IO by M bar only. If we are taking a single signal IO by M bar, it would be like this. I am drawing this. It would be like this. Sorry. It would be like this. It means this signal is zero signal. IO by M bar. It is a zero signal. Here it is high and this slant represents it is going to the zero. So it is a zero signal. IO by M bar means zero. It is because M bar is active low, so zero for that is active low. So it is a downward signal. Now, when it is merged with status, we can show like this. You can also draw this as well as this. Now, next control signal is read bar signal. Now, what happens to read bar signal? Now, whenever there is address, there is no read in this case. Whenever we require the data from the memory, whenever there is an action of data bus, at that time only the control signal is generated. So, at the mid of the T2 to the mid of the T3, this read bar signal is generated. So, it is designated by mid of the T2 to mid of the read bar is active low, so 0 is represented by this active low signal. Whenever it is low, data transfer take place. So data transfer takes place whenever it is initiated as low signal, and it is up to this point. Whenever it is high, this data transfer is terminated. So this is all about the timing diagram of memory read, and it is in general used with each and every machine cycle.